gents. Okay, this is week 12, I think, and possibly your almost last one. Okay, so I think you guys are coming on the 6th of July. Okay, it sounds like it. So hopefully the next week you're already gonna be here in live. Now, what we're gonna do today, we're gonna carry on with our theme of energy. Okay, we learned how to calculate gravitational potential energy last time. Okay, which is the energy an object has when it lifted above the ground. And today we're going to learn how to calculate the energy of an object that is moving. In other words, it's kinetic energy. And now the formula that we're going to work with is this. Okay, so KE stands for kinetic energy. We often the symbol we're going to use is letter big E for energy and K for kinetic. So EK is equal half mv squared. So how do we calculate the energy of an object? We time half by m, which is obviously the mass, time v. V stands for the velocity or for the speed. Okay, so let's just make some write what these things. This is kinetic energy. Okay, this is just half. This is your mass, and this is your speed. But we have to square the speed. V stands for velocity. Velocity and speed are not exactly the same. We're going to learn it better, I think, in grade 10 or 11. Okay. Now, we're going to have a word on units here. So, if we work with kilograms, okay, for the mass, and the speed we work with meters per second, okay, if these are the units that we're going to work with, and these are the units we should be working with, then the kinetic energy will be in joules. Okay? So, let's solve a bunch of problems, okay? Okay, so, first one, very easy. Calculate the kinetic energy if you know that the mass of an object is 2 kilograms and the speed is 5 meters per second. So we simply use that equation. Okay, I will write it down here. EK equal half mv squared. Okay? EK, kinetic energy, will be equal to half times the mass, which is 2, times the speed squared, which is 5 squared. So when you've got that, you know in maths, bod maths, we have to square before we multiply, okay? So I can do half times 2. I can multiply that, that's not a problem, but I should multiply the 5. First of all, I'll square the 5, okay? But half times 2 is 1, times 5 squared is 25. The answer is 25. Because I work with meters per second and kilogram, the answer will be in joules, okay? So an object that is moving at 5 meters per second and has a mass of 2 kilograms has energy of 25 joules. Okay? Right. Calculate the kinetic energy of the mass is 500 grams and the velocity is 1,000 centimeters per second. Now here we have to be a bit careful because we're working with different units. We have grams and centimeters per second, but we're told we have to work with kilograms, meters per second. So the kinetic energy will be equal, how many kilograms is 500 grams? 0.5, okay? But first of all, obviously I still have to write out half. So half times 0.5 kilogram. That's why I really suggest, guys, you always write down the units in your calculation. It's just a way for you to kind of realize that you're not making a mistake. If you wrote 500 grams, you might say, oh, hang on, I need to work with kilograms. Okay, so 0.5 kilogram times the speed squared. Okay, what is the speed? Speed is 1,000 centimeters per second. But I'm going to work with meters per second. Okay, meters per second. So how am I going to do it? How many meters is 1,000 centimeters? Okay, I have to divide by 100. So it's going to be 10 meters per second, and I'm squaring the 10. Okay. So I'll rewrite. I mean, you can put that in the calculator as it is, but half times 0.5 is a quarter. Okay, 10 squared is 100. So the answer says, amazingly, the same one, 25 joules. 25 joules. Okay? Great. Now, incidentally, looking at that, okay? When I look at that equation that I'm working with, kinetic energy, probably should have already started with what I'm going to say now. The energy of a moving object depends on two things, right? Okay? You know, on the mass and on the speed, okay? And if you think about it, it does make sense because energy, how do I know an object has energy? Well, for one, it will be difficult to stop it, right? Let's say if you have something that is moving fast and you want to stop it, you need to take its energy, okay? So how much energy you need to take, it depends on its speed. Obviously, the faster it moves, okay, the more energy it has. That makes sense, but it also depends on the mass. And you know that. It's much harder, for example, to tackle somebody heavier than somebody lighter, okay? Because the heavier person that run as fast as the lighter person will have more energy, has more mass. So he carries more energy, it's difficult to take that energy, okay? Now, by looking at that equation, half mv squared, okay, what do you think affects the energy more, the mass of this or the speed? Which one is more influential in this equation, the mass or the speed? If you think about it, I think quite a few people, you in the class, you would say the speed is more important. How do you know that? Because it has that square. That square on the V, on the speed, makes it have more impact, a more say in how much energy an object has. Okay, I'll pause here and we're going to go for a few more complicated questions. Okay, so our next question will need some rearranging. Calculate the mass of an athlete, okay, who runs in a speed of 10 meters per second and has 350 joules kinetic energy. Okay? So, like I told you, I hope I told you last lesson, to answer these questions, the trick here is to first of all substitute in the formula and then rearrange it. Okay, so this is the formula you'll get. Okay, and you got to ask yourself, go from letter to letter and ask, do I have that information or not? So, EK stands for kinetic energy. Do I know how much kinetic energy we have? Yes. Okay, that's 350 joules. Okay, so I'm going to write 350 joules. Half is just half. The mass. Do I know how much mass is? No, I don't know. That's what I want to calculate. So I'm just going to call it M. V. Okay, what is V? Is the speed. Do I know the speed? Here we go. 10 meters per second. So I'm going to do 10 meters per second. I need to square it. Okay, that's what the formula tells me. Square just the speed, not the rest of the stuff, just the speed. Okay, so I'm going to rewrite it now. Okay, like this. I'm going to say, okay, 350. Okay, if you don't mind, I'm going to do two things at the same time. So 10 squared I know is 100, and I time it by half, right? So half times 10 squared is 100 times half is 50. So it's equal to 50 m. Okay? And then to get rid of that 50, because that's what I want to do, right? I want to find out the n. I'll divide by 50, m equals 70. Because I work with joules and meters per second, okay? Should have written meters per second. The answer will be in kilograms. The answer is 70 kilograms. Okay? Right, so again, the trick here is, before you start rearranging, I know some of you are eager, you want to just find it, okay? You say m equal 2ek divided by v squared. Yes, you can do it, and it is correct actually, but there's a lot of chance of making a mistake here. Instead, guys, trust me, play it safe. First of all, substitute. Put the numbers instead of the letters that you know. You'll get a mark for that. Then you'll need to rearrange. And if you made a mistake, at least you got the first mark. But I think there's also less chance for making a mistake if you do it this way. Next thing, calculate the mass of a fly who flies in a speed of 5 meters per second and has 100 millijoule, I should say, kinetic energy. Okay? Right. Again, the same. I'm going to the formula and substituting whatever I know. Okay? So I've got EK is 100 millijoule. Now, instead of EK, I'm writing 100 millijoule. And I wrote the units. There might be a good chance that hang on, I need to write the answer in joules. But this is in millijoules. Okay? So I have to convert to joules. Okay? Milli means 1,000th. 1 divided by 1,000. Okay? So I need, if I want the answer in joules, I have to divide this 100 by 1,000. Okay? So in joules is going to be 0.1 joule. Okay? 0.1 joule equal half times the mass, which I need to find, times 25, not 25, times 5 squared. Okay? So I will rewrite it again. 0.1 equal half times, what is 5 squared? Is 25. Okay? So half times 25, 12.5. 12.5 m. And that means the mass is 0.1 divided by 12.5. I'll need a calculator here. Okay, so 0.1 divided by 12.5. The answer is, okay, you already know how to read that. My calculator says, okay, it's equal to 8 times 10 to the power minus 3. Okay? Now we've learned about these scientific notation. Okay? Obviously we need to write down kilogram. You can leave it like that. It's absolutely fine. Or you can write it in, this is standard notation, or you can write it in normal decimal 0.008 kilogram. That's absolutely fine as well. Or if you want to write in grams, you can write how much is 0.08 kilogram? 8 grams. Either one is absolutely fine. Okay? Right. Let's move on to a question where you ask to calculate the speed. Okay, last two questions, a little bit higher level. Yeah, the difficult kind of questions are where you ask to calculate the speed. Okay, so here I didn't make it pretty. Yeah, I know the kinetic energy is 6 joules. I know the mass is 100 grams. I want to calculate the speed. Okay, so let's have a look at that. Same thing as before. Substitute before you rearrange. Okay, kinetic energy is 6 joules. Okay? 6 joules. Okay? Half time mass. Mass is 100 grams. Okay, I got to watch out here. I got to write down in kilogram. Okay, so how many kilograms is 100 grams? 0.1. Okay, and that's time v squared. Okay, so what I'm going to do now is I'm going to write, okay, let's write 6 joules equal, what is half times 0.1? You can put that in the calculator. Okay, it's going to be 0.05 v squared. Okay? Now, I want to get rid of that 0.05 because I want to find the speed. So I'm going to divide by 0.05. Okay? If you don't mind, I'll write the answer here. So I'm going to do 6 divided by 0.05, 120. Okay? So I've got v squared is equal to 120. Now I want to find the speed, not the speed squared. So how do I find v? I square root both sides. So v is equal to square root of 120. Okay? And I simply put that in the calculator. And I got 10.95. So the answer is 10.95 meters per second. If I work with joules and kilogram, that's why I have to convert to kilogram here. Here. If I work with joules and kilogram, then the answer will be in meters per second. Okay, so it's more difficult. You have to find v squared and then square root it. Cool. Last question, which I think is quite a difficult one. Okay? The weight of the car is 10,000 Newton. Weight of the car. And its speed is 30 meters per second. Calculate the kinetic energy. Okay. So, yes. Okay. So, they didn't give me the mass. What they gave me is the weight. But if I know the weight, I can calculate the mass because of the equation that we reminded you last lesson. We learned it last year, but we reminded you last lesson. Fg equal mg. Okay, remember that? If you know the mass, you times it by g, which is 10, and you can get the weight. Okay? And this, you can go the other way around to find the mass. So I'm going to first of all write, okay, the weight is 10,000 Newton. Fg, the weight, is 10,000 Newton. The mass I don't know, but g I know is 10. So I can find out the mass in kilogram to be 10,000 divided by 10. Divided by 10. That's 1,000 kilograms. Okay? Now once I've found the mass, I can use the first equation to find the kinetic energy. Okay? Kinetic energy is equal to half times the mass, which is just, we discovered is 1,000 kilograms, times the speed square, which is 30 squared. Okay? And now we can put that in the calculator. Okay? So 30 squared is 900 really, right? So I can just do that. 900 times 1,000 times 0.5, and I get 450,000 joules. Okay? So that's a typical energy that our car has. Okay? 450,000 joules, 30 meters per second. It's fast, but it's not that fast. Okay? Yeah, that's it. Okay? So I only solved one question with a square to find the speed. They tend to be a bit more difficult, but I will give you some questions to do it from the worksheet, and I will post on the WhatsApp their memos, so please check them. Okay? And don't worry, if you're still a bit lost there, we will come back next week. We will practice more of these. Okay? We're taking our time here. Okay? But please, 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 if you don't know how to answer it, you check them out, or you still don't know how to do it, contact me on WhatsApp. Okay? See you guys. Bye-bye.